So on your warm-up, you had this log 2 of negative 29. And when you typed it in, it gave you an error. So you can't take the log of a negative. Because remember, when you're doing these logs, you're just rearranging an exponential. So like if we thought about 2 squared, that would give us 4. And 2 to the negative 2 gives us 1/4. And even if we do 2 to the 1/2, that still gives us a decimal. So there isn't a time where an exponential is going to give you a negative. Okay? So that's why you can't take the negative log of a number, or 0. So keep that in mind today as we are solving these equations. So the first thing that you need to know about solving equations is that there are certain log rules or properties. And there are 3 of them. And the first one is the power rule. And so the power rule looks like if you have 2 log x, what you can do is take that 2 and make it an exponent of whatever you're taking the log of. So it becomes log of x squared. And if you think about your exponent rules, when you have a power to a power, you multiply. So here, multiplication becomes a power. So then our next one is the product rule. So the product rule, we might have log of x plus log of y. And so addition becomes multiplication. So this becomes log of x, and then the second log and the plus sign become multiplication, so log of x times y. And again, if you think about your exponent rules, when you're multiplying bases, you add the exponents. So it's the same relationships, just the opposite. And our last one is the quotient rule. And it's when you have subtraction. So we have log of x minus log of y. And subtraction becomes division. So log of x divided by y. Q-U-O-T-I-E-N-T. So same thing, when you are dividing bases, you subtract the exponents. So in this one, subtraction becomes division. So again, it's the same exponent rules that you've been doing since Math 1, just in reverse. Because logs and exponentials are inverses of each other. Okay. So, let's write some steps to solving. So the first thing that you want to do is write each side of the equation as a single log. Okay. So if you have 2 adding, you change it to multiplication. If you have 2 subtracting, you change it to division. Then the steps from here are similar to the exponential. So the next thing we want to do is get the log by itself. So same as exponential. We want the exponential by itself. Now we want the log by itself. Okay. And now we want to change the form. So we want to change to exponential form. Then, we want to solve for x. And check the answer. Okay. So for exponentials, we didn't have to worry about checking our answer because we didn't have any limitation on an exponential. But when you're looking at a log, again, you can't take the log of a negative or 0. So you always want to plug them back in and make sure that they work. Sometimes they'll work with the exponential part, but they won't work with the log part. Let's do one. Oh wait, one more thing. So one thing that is special is if you have a log on both sides of the equation, they cancel each other out. And so the reason for that is they'll have the same base. So if you change them both to exponential form, both bases would be the same, so both exponentials would just cancel out. So rather than changing it and canceling them, you can just cancel them. And then you just have whatever's left inside the logs. Alright, let's look at this one. Let's say we have log 2 of 25 minus x equals 3. So, do I just have one log on both sides? Or just one log in general? Yes. Okay. Is the log by itself? Yep. So, everything that's over here is the log and what's inside the log. So, then the next time we do is we make it exponential form. So, exponential form, our base is 2. So, our base is still 2. And then our 3 and our 25 minus x switch. So, 2 to the third equals 25 minus x. Questions on changing the form? What is 2 to the third? So 8 equals 25 minus x. Well, now it's just a regular old equation. So how do I solve it? Good. Subtract 25. So then we get negative 17 equals negative x. Then what? Good. Divide by negative. So x equals 17. So we want to plug that back in, make sure that it works. So we can go to math to the bottom and up 1. We got log 2, and then 25 minus 17 is 3, and that's what we want. And if you're using an older calculator, again, you just do log of the big thing, so log of 25 minus 17 divided by log of 2. Either way, just make sure you close your parentheses. Questions on this one? Hopefully not too terrible. Let's look at another one. Let's say we have 4 plus 3 ln of 2x equals 16. So the first thing that we want to do is look, and we only have one log, so we're good to go there. But we want to get this ln of 2x by itself. So what do I need to move first? Good, minus 4. So then we get 3 ln of 2x equals 12. Then what can I do? Close. Divide by 3. Good. So ln of 2x equals 4. So how do I change an ln to exponential? E. Good. So e to the 4th equals 2x. And what would be my last step? Good. So we can do e to the 4th. So to get the e, you do second division to the 4th. Gives us about 54 point something, and then divided by 2. So we get about 27.3. And now let's plug it back in and make sure that it works. So 4 plus 3 ln of 2 times 27.3, and we get pretty much 16. So it's not exact because we rounded, but that's close enough. Questions? Alright, let's do it properly. So let's say we have log of x plus 2 minus log of x minus 1 equals 1. So the first thing we have to do is write these two logs as 1. So what does subtraction become? Division. So all of this minus log becomes divided by. So that looks like log of x plus 2 divided by x minus 1 equals 1. Okay, so that whole minus log becomes division. Questions on that? So now I want to change it to exponential form, but I don't have a base here. What is that base if there's not one? 10. Good. So that becomes 10 to the 1st equals x plus 2 over x minus 1. So anytime you have just a log with no base, it's an understood 10. So log base 10. So now to solve it, you have to get the x out of the exponent. So multiply both sides by x minus 1. So I'll get rid of that fraction, we know that 10 to the first power is just 10. So then I distribute that to the x and to the 1, because both of those are being multiplied by the 10. So then we get 10x minus 10 equals x plus 2. And then you can solve it however you like to solve it. I'm going to subtract the x over and add the 10. So we'll get 9x equals 12. And then what's my last step? Get divide. So divide by 9. And so we get 4 thirds. Now we still do want to plug it back into our original, make sure that works. So log 4 thirds plus 2, close the parentheses, minus log of 4 thirds minus 1, and we get 1, and that's what we want. Questions? Alright, let's do another one. Let's say we have log 5x equals log of x minus 12. So do I have one log on both sides? Yeah. So then I can cancel them out. So again, if we changed it, it would be like 10 to the log and 10 to the log, and those cancel both of them out, and so they just end up canceling. So then we just have 5x equals x minus 12. And then again, we just solve it out. So subtract the x. So we get 4x equals negative 12. And then we divide. So what does x equal? You got it. Negative 3. So then we want to plug it back in and make sure that it works. So log 5 times negative 3 is no real answer. So this is no solution. Okay. So negative 3 works algebraically because those logs cancel, but it doesn't work within the log. So that's called an extraneous solution. Okay. So it works based off of our rules, but it doesn't work with the log. Questions? Alright, let's do one more. Let's say we have log 3 of 2 plus log 3 of x equals log 3 of x minus 1 plus log 3 of 4. So we do have logs on both sides, but we have 4 logs. So we need to get down to where we have 1 log on the left, 1 log on the right. So we have to use the rules. So what does addition become? multiplication. Good. So this first one will become log 3 of 2 times x. Because again, the plus and that second log becomes multiplication. And then same thing over here on the right. So then that'll be log 3 of 4 times x minus 1. And I just put the 4 out front so we remember we have to distribute it. Okay. Well, now I look, I have one log on the left, one log on the right, so they cancel. So then we have 2x equals, distribute that 4, so 4x minus 4. And then how do I solve? Good. Subtract the 4x. So negative 2x equals negative 4. And then what? Good. Divide by negative 2. So x equals 2. So then we do want to plug it back in to make sure that it works. And you can just type all that in at one time. So log 3 of 2 plus log 3 of 2 plus log 3 of 2 again. So on the left we get 1.26. So then over there on the other side, hopefully we get the same thing. And we do, so it works. Questions?